part of this evening is a presentation by Christy Hansen. Christy is an EVA spacewalk engineer who trains astronauts to assemble and repair both the International Space Station and the Hubble Space Telescope. In addition, she is a certified Mission Control Center flight controller who supports real-time space shuttle and space station on-orbit operations during EVA spacewalks. It is her responsibility to write the detailed procedures to train the crew, as well as the procedures that are used in orbit. And she is required to troubleshoot any issues or contingencies that occur when the crew is in space. Could you please welcome Christy Hansen.
All right, how's everyone doing today? Gotta get this line of sight here so I'm not out of the video camera. It's great to be here. I'm very excited and honored to be speaking tonight. It's hard for me to believe that I am here speaking in front of all of you wonderful female engineers. And it's my goal tonight to share some of the challenges that I faced as a woman in science and engineering, going through school and eventually making my way to NASA. And I hope to do it and not bore you all at the same time. So the majority of the discussion will be on my actual job, but I have a couple charts I threw in there about some of my challenges. You can see up here, Spacewalk developer, trainer, and flight controller. This chart has some words on it here, but big picture. What I do is I train astronauts to go outside the space station or the space shuttle in the spacesuit and perform a spacewalk. So I have to tell them how to use the spacesuit, what it's made of, how to work in the spacesuit, how to lift an item that weighs 800 pounds on Earth here, how to actually maneuver that around in space without damaging that hardware or a telescope or the space station. I have to teach them to understand all of the tools that they wear on their very fancy tool belt on the front of the spacesuit. So any tool from a tether to a power tool to a special bag, it is my job to know all those tools and explain it to them, like John Harrington over there, how to use those tools. Also the mechanics of performing. So for example, you'll see shortly, we're going to go to the Hubble Space Telescope soon, and we're going to fix it, we're going to upgrade it, and add new science instruments. I need to know how many bolts are on each instrument, how many bolts, what they're torqued to, how many electrical connectors, what are the pins like, what are the electrical pin sizes, what types of tethers are we going to use, what areas they can and can't touch. All of that, I need to take all of that information and bring it down into a nice comprehensive piece of procedure for an EVA or a spacewalking crew member to follow. And the way to do that is it takes 3 different main avenues to get them fully trained. A giant water tank called the Neutral Buoyancy Lab. We'll talk about that shortly. That's where we do a lot of our training. Astronauts in their spacesuits get in the water and they work around on what we call mock-ups. We also have the virtual reality lab where they actually put a headset on, kind of like a fancy arcade. Has anyone in here ever done a virtual reality training in an arcade where you put a headset on? All right, excellent. So they put this headset on and they can actually be brought into a 3-dimensional world of the space station where they can see the Earth, either the Hubble Space Telescope, depending on what the mission is. And we can show them big picture situational awareness. I'm here, I need to get to the airlock, it's over there. How do I get there without banging the antenna that's up here, without contacting the solar array? Where's my other crew member? So it's really kind of helping them understand where they are, what they can and can't touch. And then the fun part, which we don't get to do that much about, is microgravity aircraft training. The vomit comet, has anyone heard of that? Yes. You don't want to be the one who vomits on the vomit comet. It's pretty embarrassing. So we'll talk about that in a second here. Okay, and what I'm going to do today is take you on a journey to follow me through what it's like to train an astronaut like John Harrington to do spacewalks. And I call it Mission STS-125. STS stands for Space Transportation System. 125 is the number designated for the flight. And we're going to go up, and we're going to pull the Hubble Space Telescope out of its orbit. We're going to pull it into the payload bay, and we're going to install new science instruments in it. We're also going to repair some things that are broken. And this will be the very last, what we call servicing mission. And this is the last one NASA's going to fund, theoretically, last one that we're going to fund, and actually go up there October 8th and fix it and let it go and be on its own for a long time. Has anyone in here heard of the Hubble Space Telescope? Yes. That's great. None of the kids did. Okay, so, and then I had to back it up to the whole concept of an orbiting telescope. Okay, these are just my quick women's study slides I put in here today for you. And I know that's not a space picture, but this is one of the things that has made me stronger. And today I want to show you kind of my background as a woman engineer. These are some of the major questions that I kind of wanted to bring up and tell you about. My dreams, where are my dreams? How did I get where I was? Was it easier for me and did I have any unique challenges? How did I overcome my challenges? So on subsequent slides, I'm going to tell you about what these challenges were, and some of my famous quotations I'd like to share with everyone. Some of these guidance counselors, and their motivational skills that they give you. And I know all of you are already successful women, but I do want to tell you about what my journey was and some of the stuff I had to deal with. And if you look in the right-hand column there, those are 4 of the characteristics that I'm sure everyone in this room has. And when I was speaking earlier to some of the kids, I was trying to let them know, as young women potentially wanting to go into science and engineering, to not listen to any negative feedback from anyone who tells you you can't do it. I had a lot of people tell me I couldn't do certain things, and all that did was make me mad. And I kind of wanted to instill that in some of the new people. That someone says something, then you doubt yourself, maybe I shouldn't go into it. Maybe it is hard. I think it's probably hard for everyone. It's not just hard for me because I'm female. We'll talk about that in a minute. What were my dreams? I've always wanted to fly in space. That's my dream, and that's all that my dream has ever been. And right now I feel very fortunate because my job at NASA currently gets me probably as close to flying in space as maybe any other job in the world. Because I have to train the astronauts to do the right job. So therefore, I need to go through some of the similar training, like working in a spacesuit, in the water tank, flying on the KC-135, and all of that. So that gets me prepared to do things. Was it easy for me as a woman? I would never say it was easy. It was never easy. But one thing I will say is that I did have a lot of drive and determination. And even if I had self-doubt, even if I knew maybe I wasn't as smart as that person over there, it didn't matter because I was going to pretend to be. Or I wasn't going to let them tell me that I wasn't. That was going to be my goal, whatever I had to do. And you'll soon see, and I think all of you know here, that drive and determination and being a hard worker and being dependable and all those things are the skills that you need to get you where you need to go. Okay, this is my favorite here. So I put my favorite motivational quotes. The reason I have these climbing pictures is I think it's important, and I told the kids today, to have hobbies that you love outside that can build other skills like leadership and teamwork and being courageous. I recently took up mountaineering, and it is kind of scary, but I find that you get out in these cold, harsh environments that maybe could be an analog to a harsh environment in school or working. And maybe you're a little scared, what am I going to do? But your direct actions will impact everyone around you. And in mountaineering, you're on a crevasse or a glacier, you're roped up to other people, and you do everything you can to know what you're doing because you don't want to let anyone down. And I find that parallel can be drawn with, I don't ever want to let anyone down at work, and that's one of my big motivators, is to make sure I know what I'm talking about so I can earn the respect so that people will listen to me. These are just some funny quotes I wanted to share. Let's pick one. Okay, here we go. This one right here. One of my graduate school professors said this to me. We were working, there was me and 4 guys working in the office, and he came up to me one day. Meanwhile, everyone does their work. Everyone gets their work done. We're in grad school. We want to be there. Keep in mind that because you are attractive, it can sometimes be distracting to your coworkers. So if you could, anytime they come over here to talk to you, just get up and move over to this location, that would be fine. I mean, how would you even respond to that? And I just looked and I'm like, God, I'm so sorry to be so good looking that no one can even get their work. God, it's really hard being me. Anyway, so that actually was said to me. Let's find another good one. Okay, yeah, this one down here at the bottom. When I was trying to decide where I was going to go to university and what I was going to study, it was probably going to be physics or engineering. So I met the dean of engineering at my university, and I sat down and wanted to learn more about it. And what he said to me was, not to sound sexist or anything, and that's a really good way to start, isn't it? But you don't look like the type of person who could be an engineer. You don't look like the type of a person. And this is when I was younger, and I speak my voice now, and I'm pretty honest and let people know how I feel. But back then, when you're younger, that could have deferred someone or deterred someone from doing what they want to do. And I couldn't believe this guy was sitting here telling me this. And then he continued with, it's going to be a lot of work. Have you considered communications or something like that? And then you could also have some extracurricular activities that you do and maybe have more fun while you're at school. So someone actually said that to me, and I consider this a modern world. And then here, well, sometimes women tend to be less inclined toward math and sciences. It's okay. So these are some of the things I've heard, and I can laugh about them now, but it made me angry. And all that did was make me want to work even harder to show them that I could do it. Okay, this is the last leadership, and then we're going to get into my job. So my perspective of leading teams as a woman. This quote up here, somebody said this to me, Christy, you're going to take all of those men down underwater with you to show them the space tools, and they're going to listen to you? And do you know who said that to me? My grandmother. My grandmother said that to me. She actually, when I got the job at NASA, she was just so perplexed. She's like, what are you going to do? And the thing is, and I couldn't believe she said it, but at the time I thought, what am I doing? Yeah. How am I, this new graduate out of school, I don't know anything about space. I did well in school. I know engineering and physics. And I'm going to take someone like Harrington or someone who's flown 5 times, and I'm going to tell them what to do. And you don't want to admit that you're nervous or scared, but you're like, suck it up. It's going to be fine. So I talk about what you're going to do here. there are different leadership styles. I was asked to speak about what it's like to be a leader and how you can control a bunch of people in the classroom and why are they going to listen to me. You know, and I did have doubts when I went in there, and I would never share that with anyone at the time. But the thing that I learned is you have to earn the respect of people. And if you earn their respect, regardless of who you are, they will listen to you. And the way that I found that as a new person, to learn this respect or earn it, I wanted to know every detail about every piece of hardware. So you have these astronauts who've flown 5 times in space. They've done all these spacewalks. What can I possibly give to them? But they also have to know 8 million things about 8 million other disciplines, like the power system on the shuttle, the thermal system. How does the toilet work? Where's all the food? How do I heat things up? So they don't have the time to know all the little details about, on this piece of hardware, we have 16.5 bolts. They're all torqued to 14 foot-pounds. If that 14 foot-pounds doesn't release, we can also go up to 16.5 before we break that bolt. And they can't touch this surface because if they touch it, they're going to degrade a thermal coating, and then that science instrument isn't going to perform as well when it's in the Space Telescope. So I found that by digging into all those little details there, and I'm sure all of you know this, that's something that I could contribute. And slowly they'd start to, you know, you'd earn their respect, and then they would listen. But it was intimidating at first. So, I mean, I'm sure all of you have experienced that. And I have a different style. There's a lot of styles in my group of how people train. Some people are it's all very official. Some people aren't so good, I think, but I like to be honest, and I like to be honest with the crew members or astronauts that I train. And I find that being honest with them and not BSing around or anything like that does earn their respect and does try to get them to listen. And you'll see in subsequent slides, trying to teach a crew what we call a 1G. It's a 3 to 4 hour session outside of the water tank where you walk the crew in a high bay. We go to one piece of hardware and we point at the hardware. This is the new wide field instrument we're going to install. It has 3 bolts. Don't touch here. Now this is what you have. 2 crew members who are very experienced, who are already bored with the 1G. So they're over here and they're talking and having a side conversation. And you have the new guys who are like, what? You know, they're listening to everything. But really everybody needs to be listening together. So you can't assume the experienced guys know everything, but they think they do sometimes. You know, and the new guys, so that is a challenge that I face every day. And then what do? You know, so then I'm like, you know, I do one of these looks like, the class is over here, can we get back together and do that? And then they kind of laugh, and it kind of puts an element of humor to a serious situation. So we have a good team and we get through all of our stuff. Maintaining focus is challenging, and this is kind of funny, and this is true at the bottom. Sometimes it's like herding cattle around when you're trying to show the hardware, and that's what it is, because we're all here looking at a carrier. Okay, guys, if we have a problem, we're going to pull that tool out. I'm talking. Next thing I know, I look behind. One guy's here, and the other 2 are on their phone, or I don't know, someone's doing something else. So it's a big challenge for me, but I really enjoy it. Okay, most of my discussion today will be on the mechanics of fixing the Hubble Space Telescope. But I just wanted to show some pretty pictures here because people wonder, who cares? We're sending an astronaut up there to do what, and why do we care about this? And I think most of you are probably familiar with some of the big things that Hubble does, but the architecture of the universe, size and shape of the universe, all the pretty pictures it takes. We say recipes for building planets. There are so many different, there's 4 what we call axial science instruments and 4 radial science instruments. And all of them see a different band of the electromagnetic spectrum. So we can learn different pieces of information about different parts of the universe with all the new instruments. So we're going to change out some of the older ones, put new ones in, maybe learn about dark matter, the life story of galaxies, the birth and death of stars. Does anyone know what this picture is? John, don't answer. This is John Harrington's favorite slide. I deleted it to save time for my other presentations, and he would end up pulling it up after his to talk about it. That's how much he liked it. This is the Hubble Deep Field. And what you're seeing here is just a small, and I'll just keep it simple, a very small percentage of the sky. So if you hold maybe a small coin up, point it up at the universe, maybe just like 1 degree or something like that, and point Hubble. Hubble has a bunch of gyroscopes and reaction wheels. I can hold it, point it so finely so that it can actually see the same area and not move for roughly 10 days. So all this light's coming in, the instruments are recording this. This is what we see. This is the deepest look into the universe that we have. And what the kids don't understand is they see these bright dots and they think each one of them is a star. Each one of them is a galaxy. All of these galaxies, there's millions of galaxies, right? This is just in a tiny part of the sky. And then what I try to show them is one of those dots is this, a galaxy close up that also has billions of stars. So just to provide insight and awe to them and wows and all that. Okay, let's get into what the mission is about. Hubble Space Telescope. This is the Hubble. It's berthed in the payload bay. The payload bay is right here. And I won't get too detailed, but if you follow each of the arrows, that's what we're going to fix and upgrade on this mission that launches October 8th. So just to let you know, we have some batteries. You can follow that there. We're going to change those out. Wide field camera. The wide field camera is the one that takes the pretty pictures of the planetary nebula, like the Eskimo Nebula, Eagle Nebula. We have a fine guidance sensor, which points the telescope, some blanket layers. We spend a lot of time at Goddard Space Flight Center doing what we call hardware visits. So that's part of my job, to go with the crew into the clean room at Goddard. And what's special about the clean room is that we can't train on the real telescope because it's orbiting right now. So we have a full-scale mock-up. That's what you're seeing. So it's the same size in every dimension. Mostly the same materials, but it's okay. It's more robust. We won't damage it as much. And this is where we tell them, guys, this is how the doors open. Okay, when you open the doors, you can't touch anything inside them. All the black, that's special MLI. It's very delicate, and if you go like this, you could flake off a piece, and now you have floating debris inside of a telescope. And I think people can probably imagine why that might be bad. That debris is going to float up and get in the aperture, the opening in the top of the instrument, and it's like getting a fingerprint or a piece of hair or something on the lens of your own digital camera. And you try to take a picture, and it's blurry. So what you're seeing here is the astronauts wearing what we call bunny suits, and that just protects all the instruments and the lenses from any hair or oils or debris that could get on anything. I just like to put this in because I'm in the picture, just so everyone can see me on the slides. So John Grunsfeld is our most experienced astronaut on my left right here. Drew Feustel's new. We're wearing the bunny suits. And the cool thing in the background is you can see this new wide field camera hanging from a crane. So you can imagine that's roughly 700 pounds. So part of my job is to train them on how do you maneuver something that's 700 pounds on orbit. We'll get to that in a minute. Okay, another picture in the clean room. This is that same instrument pitched over 90 degrees. And I have a sign that says no touch areas. So we tell them, take this 700-pound instrument, put it in the telescope, but don't touch 90% of what you're doing. Don't break the mirror off. Don't touch this part of the telescope. Don't touch any of the black or the front of it. And the crew member's holding it like this, and all they can see is the instrument. So how are they installing it? And you'll see in a minute how they do that. Neutral buoyancy tank. We do most of our spacewalk training in here. The neutral buoyancy tank is a large swimming pool. I'll call it a water tank from now on. And it has mock-ups of, you'll see the space station. That's just a picture of what the space station looks like at assembly complete. These are just mock-ups of the space station underwater. And then this payload bay here is where we do the Hubble Space Telescope training. This is just a photo of it. 12 meters deep. It's huge, 32 by 62 meters. 6.2 gallons of water, million gallons of water. And this is really the avenue where, on the next slide, we put the astronauts in the spacesuits. We fill the spacesuits with air. And of course, they'd fly up to the top of the pool. So we have divers put weights on them, weigh them out so they're what we call neutrally buoyant. Looks like when they're on orbit or in space, actually doing a spacewalk. So that's why we do this, to teach them translation paths, what not to touch. As an instructor, I get a chance to get in the spacesuit and work. I also, sometimes we have a little bit of fun when we can, but I got certified in scuba diving there to learn about taking astronauts down and showing them what they do before they get in the spacesuit. So I take them all down. You can imagine the limited communication when you're trying to talk to someone. You can't talk because you have a regulator in your mouth. And it can become a flailed, discombobulated nightmare very quickly, and I've seen that happen. So you have a detailed plan on the pool deck. You get down, you look at them, step one, you point, do that, then they do it, point, and you have all these papers and they're moving around, and you hope your clipboard holds the papers, because one time mine didn't, and then papers were all around in the NBL like that. So this is that wide field camera again. This is in the pool. That's the Hubble Space Telescope. This is Drew Feustel. He's on a robotic arm, but you can't really see it because it's out of the view. And he's installing this instrument into the telescope, that slot, but he can't see anything. So he has to rely heavily on his other astronaut crew member who's hanging onto a handrail, and it's that guy's job to say, okay, come in 3 inches. So he comes in 3 inches. Translate left 2 inches. He translate left 2 inches. Pitch mirror end up 2 degrees. So they have to really rely heavily on verbal feedback to be able to do this. This is just another view of the instrument going into the telescope. Okay, this is kind of a nightmare picture. You want to try to avoid this. Everything that's hanging on this astronaut, these are all tethers and tools that he is required to carry so he can tether everything that's out with him. Everything has to be tethered. You don't want to lose it. You can see how everything's hanging in gravity here, but you can imagine on orbit you're translating, and those aren't going to be hanging down. They're going to be floating up in your face. So you want to be smart about how you carry your tools. So I try to teach techniques for how to do that, but everyone has their own preferences. Those metal hooks, there's an antenna up there. Okay, I don't want to have a metal hook fly up and hit that antenna. I need to be careful of that. I'm going this way. I can't put my hand in this area. It's a sharp edge. I don't want to do that. So we have to tell them everything that they can and can't touch. Okay, I'm going to move fast. Virtual reality lab here. This is that high fidelity arcade I was telling you about. They're wearing headsets. They have gloves with sensors on them. Alec actually did this when he came to Houston. That's actually a picture that's you. That picture is from when you were there. I took of the screen, actually. So this takes these astronauts into a world simulating the space station or the space shuttle. And then this is situational awareness. Where am I going? What does everything look like? This is a picture of that same software, kind of just like cartoon software, with the telescope, the robotic arm, the astronaut holding the instrument. So we do a lot of training there to teach them, okay, you're going to be on the arm, it's going to be in this position. The thing that I can't show you in a picture is what we call our mass simulator. This is a very important trainer. It's also in the virtual reality lab. So that instrument that's roughly 700 pounds, we give mass property data to the software lab, the CG, length, width, height, mass. They can model it, and then it gets transported into a machine. And the astronauts can actually stand there holding a machine, wearing the headset. When they have the headset on, it looks like they're holding the instrument, but it's just like some square handrail. And they can actually move. We can translate up and down, plus or minus 2 feet from zero, and that, to get the feel for what moving a large mass, just feeling the inertia of something on orbit. And if you put a rate in it, it's something you don't think of. Okay, I put a rate in it, it's going up. It's just going to keep going up. It's going to go up until you stop it. So we teach them how to do that. And we teach them to not put a translation in and a roll, because that's harder to get out. So we do things like that there. This is probably the most fun thing. You don't get to do it a lot, and it really is a lot of hard work, but people talk about the fun parts of it because that's what folks are interested in. But the KC-135 or DC-9 microgravity aircraft, where we test out new materials, science experiments, and just have astronauts get the feeling of free fall. It's really the only place on Earth where we can do that. So the airplane flies in what we call a parabolic trajectory. I'm sure all of you are familiar with parabolas. It does roughly a minimal 40 parabolas per flight, sometimes up to 80 when there's a lot of work. At the very top of the curve, as it's going over the top, you get 20 to 25 seconds of free fall. So you just have short spurts of time to do any testing. And after that free fall, you get to the bottom and you do the 2G, what we call a 2G pullout, which can be kind of uncomfortable. It's a little uncomfortable. You feel double your weight. And we tell everyone when you're in the 2G pullout to try and look forward and not move your head around. Because when you start doing this, you have all sorts of sensory conflict theory. Your eyes see one thing and your body feels another. And they require us to wear throw-up bags stuffed all over our flights. And not in the zipper. It has, and I'm like, I'm not putting it in the zipper. I had everything out. Depending on where I was, I wanted to be able to grab it and not make a huge mess, because I've been on the plane when there's been a huge mess before. Okay, this is just a fun picture. That's myself, Swedish astronaut, and a coworker testing the dynamics of a new 80-foot safety tether that we fly. The safety tether is what's required for the astronauts to wear so they don't float away. And there's specially designed materials and hooks so that if they do let go of structure, that's going to pull them back. This here is a Swedish astronaut holding on to what we call, this is a fun, funny picture, I think. He's holding a durometer, which is an instrument that tests material hardness, and he's rocking it on the ground, and he wanted to understand what his body positioning would be. And we're just simulating the mass of a spacesuit, roughly 300 pounds, and we didn't have a spacesuit, so we're kind of just latched on his back. This was the last parabola. We thought it would be fun to do. My job, part 2, just real-time flight control and the Mission Operations Directorate. It's my job to know every little detail. So if something fails, what do you do? If this fails, what do you do? This bolt broke. What are we going to do if the bolt breaks? The crew has to collect all the loose pieces, put it in their little trash bag. Did any pieces get inside the telescope? Did some of the multi-layer insulation come off? What are we going to do? Any anticipated failures? These are pretty pictures from flight, previous Hubble missions. There's the telescope. This is an astronaut on the robotic arm. And you can see in front of him, he's working with all of his tools. This here, what's the word? Phone box? I always forget what you call it here. Phone booth? The phone box. One of the instruments we're changing out, it's the old COSTAR, Corrective Optics Space Telescope Axial Replacement. There's a lot of acronyms. And it's the instrument that essentially saved Hubble when we found out the primary mirror had the spherical aberration and all the pictures were blurry. This instrument was put in right away, and it has a special lens that flipped out on top of all the other lenses to correct. And now all the new science instruments already have a correction in them. So we're taking that old COSTAR out, and we're going to put a new instrument in on the next flight. But this is just to show you what one of these masses, it looks like a phone box. Just like you'd see your red phone boxes outside. That's essentially the size of it, 800 pounds. On STS-109, the last Hubble mission, this is an example of troubleshooting. That giant rectangular white box is a radiator, and the crew members went to install it onto handrails, and it wouldn't fit. It wouldn't go on. And what do? It's not easy. You don't have a lot of time. You have 6.5 hours. We're 5 hours into the EVA, and the radiator won't fit onto the handrails. What are we going to do? So John Grunsfeld, he's the most experienced, and he's like, I think I can just, there's a thermal skirt, and he's like, it's a little stiff. I think if I put a little bit of motion into it, I can probably get it to go. So he called the ground, can I impart more loads into the robotic arm? Because if you impart too many loads into the arm, it could move inadvertent motion. So we give him a go to do that, because it was very important. So he counts to 3, 1, 2, 3, rocks it on, gets it on. Now it's crooked. It's on there, but it's crooked on the telescope, so we joke about him. Who put that on there? But at least it's on there. And while he did it, he did slip what they call joint brakes. Each of the joints in the arm have brakes, and if you put too much force in them, they kind of move a little bit so you don't damage the hardware, but it was fine. This is a picture of the crew. The 2 guys on the end here are doing 2 of our spacewalks on Hubble, on the Hubble mission. Those 2 guys are doing 3. Megan MacArthur, yes, the female on the flight, her job is to capture the telescope in orbit. She is, I'd be like this, very nervous. She has one chance. Hubble's orbiting, it's moving, so it's not even a fixed payload. The space shuttle's moving, so they're both moving. She flies the robotic arm using camera views, and she has some window views, flies it to actually go, grab onto the telescope, and pull it into the payload bay. This is just some fun picture. Never give up. Okay. All right, this is just a fun KC-135 video. We're almost done here. How's everyone doing?
Good.
You're good? Okay. This is one of the rare fun moments that you might have to do some spinning. You can see all the white bags. Those are all the throw-up bags, so I can easily get to them if I need to. Okay. You're all doing a great job. Okay, here, hold on. I like to show this video. Okay, this is a video, an artist rendition video of, it's very cool, of what we're going to do, launched October 8th. Just a high-level summary of the instruments we're going to change out and what the payload bay looks like, and it's really pretty. It's one of the inspirational videos that you see sometimes. There's some cheesy music that comes on here soon, but. Can we dim these lights here? Is there any way, or is that going to impact negatively your filming? Just because it'll look better, just these forward lights. Okay, so you can see the shuttle. Can everyone hear me okay? The shuttle's rendezvousing close to the telescope, and Megan's going to fly the arm and grab it and pull it in the payload bay. So you can see the robotic arm. She's going in to grapple, to grab onto it, pull it down. Oh, that's good, thanks. You don't want to mess up and hit the wrong thing and bump it off, and what are you going to do then? So she pulls the telescope down onto what we call the flight support structure, and it has 3 latches, and it grabs onto the bottom of the telescope, pulls it down, and then that platform can actually rotate so we can get access to all sides of the telescope. And there, it zooms in on the latches here. This is kind of funny. This is a view of someone inside the telescope watching someone outside open the doors. This is an astronaut getting ready to pull out that corrective optics, the old axial science instrument. He's using a ratchet wrench, breaking torque on the bolt. Pulls it out, it slides right off of guide rails. You can see he doesn't have great views. His face is right here in front of it, so he's relying heavily on the other astronaut. This astronaut's opening what we call a carrier. It has the new science instrument in it. Now he has the new science instrument, and he's getting ready to slide it in. It's a spectrograph. This one is a spectrograph. Slide it in. And this is not trivial, by the way, and this is sped up. It's very, very slow on orbit. Are they there yet? Are they there yet? This is our power tool, our very expensive power tool, but it has 14 different torque settings in it, 6 different speed settings. It's our, the primary tool we use out to drive bolts while we're doing the spacewalks. We're putting on some new thermal protection onto one of the bays. We call it a cookie sheet because it looks like a cookie sheet. Now this guy here is getting ready to open the doors to pull out the old original batteries. We need to put new batteries on the space telescope. Meanwhile, the little rectangular, these things right here are called thermal louvers. Those are sharp edges, so we can't touch those. They just help cool the batteries inside the bay. Now he's demating what we call all the electrical connections. He's demating them. They all have little pins in them, so every time they demate it, they have to check for any bent pins. If one is bent, we have a special tool we can get in there and straighten the pin. The other guy is down here in what we call foot restraint. We don't want him floating around, because what will happen if you drive a tool that rotates and you're not attached on the other end? Right. So now they're pulling the batteries off. Oh, he's closing the door. If you look very carefully, the tool's actually turning the wrong direction. It should be going clockwise. That's just a funny little video thing. This is probably the coolest thing I think we're doing. He's pulling out the old wide field planetary camera, pulls that out, and they're going to temporarily stow it on the side of the payload bay. They stow it on these little forks, and they put a special pin in it to hold it in place. Now we pull the new one out of the carrier. He's on the robotic arm. Megan's flying the robotic arm. Now we go in. He's relying heavily on this crew member to guide him, or what we call GCA, ground control assist. He's putting it in. It goes a lot slower than that, really, in reality. This is kind of cheesy here, but it's good anyway. So he closes the doors. All right, that's it.
Does anybody have any questions for Christy then?
How long does that battery last that you're putting in, 2008?
Well, the rough period of estimation for how long all this stuff will last, I mean, there's multiple limiting factors. It could be the gyroscopes that maybe they fail and we can't use the telescope anymore, but the batteries are supposed to roughly, what I'm hearing is 5 years. Once we replace all these parts, the telescope is ready to go on its own for 5 years, but most people really think up to 10 years of time once we change those out. But other things could fail, like the gyroscopes, some of them, like 4 of them, we have 6 gyroscopes, 4 of them are not working right now. So I think other things would probably fail before the batteries would stop working.
Can you work that back down to laptops? And,
Yeah, right. We're just a little bit behind, one step behind on the laptops going on there. Anyone else? Did everyone enjoy? Oh, go ahead.
How long does it take to get to Hubble to do this work?
So it roughly takes 8.5 minutes to get into low Earth orbit when the shuttle launches. And then we do, let's see, flight day 3, roughly flight day 3, so 2.5 days roughly to catch up to the telescope and grab it and pull it in the payload bay. 2.5 to 3 days.
What do you do with all the bits you take out?
With all the what?
The bits you take out.
Oh, that's a good question. Yeah, we didn't really talk about that. So there's a special device on the side of the payload bay called the aft fixture. And what we do is when we pull an old instrument out, we have to pull it out, and right now there's nowhere to put it when we pull it out. We can't put it back into any carrier because they're all filled. So we move over to the side of the payload bay, and we temporarily stow it on there. And these little forks, they go on the handle. So it's just kind of hanging out over the wing. Then we go and open the lid in the payload bay to the carriers. We pull the new instrument out, put it in the telescope. Then we go back to that aft fixture, pull that old one out, and it goes back into that carrier where the new one came up. So we bring them home with us in the carrier. If we have any problems doing that, let's say we try and put it back in the carrier, you could jam. Maybe we can't. You think about safety. There's so many things to think about. Safety of landing. We're required to get 22 turns on wide field when it goes into the carrier. 22 turns and our minimum torque. And if we don't get the minimum torque, it's not safe to land. It could jitter around and come out of there. So if we have problems with that, we have to take the whole thing out and jettison it. I mean, get rid of the instrument. So we have to train the crew to be ready for all those failure scenarios. So hold the instrument. The robotic arm flies to a jettison position. And there's different ways of doing it. The astronaut could let go and the vehicle could back away, or they could push it. So we try to take things home. They'll probably end up in the Smithsonian or something after this is the last flight.
What were you doing before you did this job?
School.
What prepares you
Yeah.
for this unpreparable
Nothing.
full
Not really
day?
anything. I was in school. I was very fortunate to come right out of school into this job because most of the people come from other areas and disciplines. So I have a physics background and I have a master's degree. But I didn't even know about this job until right before I graduated. I think there are people there who do that. But it's really opened my eyes to, like, there aren't just astronauts. You know, there are thousands of people on the ground that are getting them ready to go. So I had to go through extensive training once I came to NASA. I mean, I didn't know anything about spacewalks. I mean, you have the brains to know, but you don't know anything. You don't have any experience. So I had to take a series, almost like all the classes I'm teaching them now, I had to take as a student. I had to take it. I had to practice to teach it. Then I had to certify in it. And once you certify in everything, then they quiz you and they question you. They assign you as an on-the-job trainee to follow another experienced person around to learn about the job. You know, if you pass all those tests, then they will assign you to your own flight. So you get assigned roughly a year and a half out from a flight to train, at least for the spacewalking group. That's what we do. But you don't have the background. It's kind of overwhelming a little bit.
I was also struck with the other part of your job, the flight controlling. That must be very, very stressful. How do you cope with that?
First of all, for me, it's very stressful. Some people think it's all, it's very fun, we're going to go, and I can't even sleep. When they're up there doing it, I don't even want to sleep. I want to sleep in mission control, so I'm there. We have to depend on our planning shift. So I'm prime, meaning I'm the ones who train the crew. I sit there when they're doing the spacewalks. I'm ready for problems. But then at some point, I have to go off console and sleep and let my planning shifts come in, other people like me who are there overnight in case questions come up. And it's very stressful because I'll tell you what, you plan, 500, we have a 60-page document on anything that could fail over these 5 spacewalks. And most of the time, it's other things that fail that aren't even in there. So you're like, why did we spend all this time doing that? I guess so those wouldn't fail. And I'm on the edge of my seat. I'm like, what we do is we talk, my coworker, what's going to fail next? What page? What's going to fail next? I can't even enjoy it. I'm like, okay, here they are. Okay, what if this torque value doesn't work? Go to page 5-2 in the crib sheet. So you're not wasting time. If it fails, you're right there. You're not like, oh, what happened? What page do I go to? And it's just this constant, this constant state of awareness the whole time. And until they close the hatch, you can't really breathe or relax. At least that's how I feel during it. John Harrington, what's up?
Sorry, question. If the arm doesn't work, can you still install the wide field planetary camera?
That is such a good question. Let me tell you, if the robotic arm fails, what are we going to do? Because all these masses are super heavy and they're hard to maneuver around. We actually have, and we just did our training last month, what we call they're called no RMS. The RMS is the robotic arm. No RMS procedures. And they're not pretty, right? They're not pretty, and we can't do full EVAs or full spacewalks, but we set up a series of foot restraints, and we do leapfrogging. So we set foot restraints the crew member can put their feet in, and they lock on the structure. And we kind of, 1 foot restraints in the side of the carrier, 1 foot restraints on the sill. The guy in that foot restraint by the carrier pulls it out of the box himself, holds it. Then he hands it, and it's not this ideal right in front of you. It's like, do you have it? The other guy puts his tether on it, he has it. Now this guy gets out of the foot restraint. He moves over closer to the telescope. He sets up his foot restraint. It's like seat to cart relocation leapfrog like you did on 11A. Anyway, so they kind of set these foot restraints up. They work their way over to the telescope, and it's a lot of this, pull it out, maneuver it, it's over your head, the other guy gets it. So we do have published procedures to fly in case the arm fails, but we will only do 1 task on 1 spacewalk. We won't try and do multiple tasks because it takes a lot longer. It's a little shady, but we can do it.
Did you say you've done the space station as well? You're
Yes.
involved in that as
My
well?
last flight was STS-116. We installed a port truss segment on the space station. So most of my work, because of the Columbia accident, there were a lot of delays in the space shuttle flights. So I was actually with the last astronaut team for 5 years, training the same crew. You usually do 1.5 years, 5 years with the last crew. And yeah, I mean, it was a great flight. So in my group, I feel fortunate because I get to work space station and space shuttle and Hubble and training and flight control. Whereas other groups, they're just trainers, or they're just flight controllers, or they just do space station, or they just do shuttle. Whereas our group, there are about 40 people, and we're expected to do and know it. And it's a lot of self-study, a lot of initiative, and calling and harassing people to get the information that you need.
Still want to go to space yourself?
Yes, yes, I do.
When are you going?
I don't know. Can anyone in the room answer that question? Well, it's very hard to be selected to become an astronaut. And we have a bunch of astronauts in the room who know how hard it is. And they haven't opened up an astronaut application class for a long time, since Columbia, but they recently opened up a window last September to this July. But you can imagine thousands and thousands of people are applying. And I would say a lot of those people are very, very qualified, but they're only going to maybe take 12 to 14 people. And why would they take me? Why are they going to take him, her? You never know. And you do the best that you can, and you do what you enjoy so that you're not disappointed if you don't get picked. But you keep trying. And folks have applied over a series of 10 years before they've been picked. So you really need to keep trying. And like John says, your quote, John, you're never going to get picked if you don't apply. You might get picked if you do apply. So you increase your probability a lot if you actually submit the application.
Is there a European space program?
Yeah, there's a European Space Agency, and ironically, I mean, it's a lot smaller. They don't get as many flights, but they actually have, it's kind of in parallel with our application process. They're taking in new astronauts, they're calling them astronauts also, this year. So I don't know how many they take and what their process is, but they do have their own astronauts that fly. Oh yeah, I think go ahead.
How easy is it to communicate with the guys when they're up there and you're down here?
Oh, it's frustrating. It's so frustrating. There's a whole chain of command. A chain of command, and to me, I just feel like it's slow. I don't know how you guys feel, but we're so used to being with them side by side in all of our training classes. And if they're doing something wrong or something's not working in the water tank, we wear the headsets in the test conductor room. We can call down right away. What are you doing? No, we didn't. But when you're working the mission, we can't have 500 people calling up at once and causing chaos. So there's one voice, the capsule communicator, usually an astronaut, who's very good at communication, and taking a lot of information and succinctly, guys, what we need you to do is increase the torque to 5 foot-pounds. That's a setting of alpha 3 on your power tool, and go to 5 turns. So they take all this and it goes up. But a lot of times you have to listen carefully, because our flight controllers, the spacewalk ones, will talk to each other. Then that goes to the flight director. The flight director has to think about it. Does the flight director agree with it and understand it? Then the flight director tells the capsule communicator, and then they read it up. And sometimes there's so much communication, we listen to loops, and I can hear the flight director, I can hear my coworker, I can hear Goddard Space Flight Center calling me all the time, and everyone, and you have to hear, okay, who's calling me now, which one's more important, stand by. And then I'm listening, are they calling it up right? Because there have been times when maybe the capsule communicator doesn't call it up correctly. And it's my job to make sure, okay, oh, I didn't say alpha 3, so you have to break, no, alpha 2. And so I sit there, I'm like, oh, I wish I could talk to them directly, and which you can't do. So, but that's to make everything more, the communication be a single voice and everything like that. So it feels like hours to me for something to go up, and I know it's just maybe 1 minute or something, but.
And how long have you been planning for this? 2B question. How long have you been planning for this October thing? And then when it happens, will the rest of the world know what's going on when you're doing it?
Oh, yeah. Well, I should say I've never, in all of the missions that I worked, have seen such publicity, like NOVA and the Discovery Channel, because it's a big deal. The Hubble Space Telescope is a huge deal over in the States, and a lot of people have attachments to it because it brings the pretty pictures of the universe, and we've learned so much about the universe. And so it's going to be highly televised, at least over in the United States. I mean, we have the NASA channel, but all of the major TV stations are doing specials on it, following our training around, like at a lot of our classes. So it will be highly televised. I'm not sure over here. I know you can download, nasatv.com, and pull up NASA TV, and you can watch it. I mean, they will have continual footage on NASA TV of everything that's happening. So you can at least watch it that way.
But how long have you been preparing for this one thing?
This mission? Hubble, for some reason, they sometimes get longer periods of time for their training, but the average is 1.5 years. You get assigned to work with your astronauts roughly 1.5 years before you launch. By the time we launch with Hubble, it will probably for me have been about 2 years. But it ranges, but roughly 1.5 years to get through all of the stuff. And they have so much other training they have to do too on top of it, more than just spacewalks.
Do you find, or do you think there are any hindrances or benefits to being female as part of the team or as part of the management leadership team?
You know what? I am happy to say most of the crap that I had to put up with, like with these quotes and things, were in school. Like my undergraduate, my graduate, even in my high school with my guidance counselor, getting special permission to take physics 2 because it's going to be hard. But thanks for telling me that, because I didn't think that I would know that. But at NASA, I am very, very happy. Most of my group, I think just slightly over 50% are female, and I've dealt with jerks before, but not in a sexist you're female way. Just but there are mean people in lots of organizations, but I haven't felt that because I'm female. I've gotten less respect. I really have not ever felt that at Johnson Space Center, and I will never take that for granted, because I know out there, like in society, I hear my friends who are female engineers in oil industries, and have to deal with a lot of bad stuff that goes on and stereotypes and things, but I have not found. And the thing is, like, one thing that helps me is I really care about, when I get with the crew, I know them really well, I really care about them, and it makes me want to work even harder, because now they're your friends who are going up there. You don't want to let them down, and so we form these tight families, and everybody cares about each other for the most part, and so that kind of helps. But I haven't dealt with any difficulties. A lot of my role models at NASA are females who are leaders, ones that are higher above me, and I look at their leadership techniques and what did they do to get there. So, I mean, maybe the experience was different for other people, but at least at work, I'm glad to say I'm hoping that's done with. Anyone else?
Anybody else?
Yes.
Well, if you could give one piece of advice to female students in engineering, to help prepare them for the workplace, what would it be?
I guess one of them is to not have assumptions. I assumed a lot of things, and then I was shocked. So to keep your mind open, and to be strong and expect the unexpected. You have these expectations, and then you go somewhere and it's not that way, and you're disappointed or you're confused. I would just say, work hard, be communicative, be a team player, always be a team player, listen to everyone. I think The most important thing is to listen to everyone's opinions. People will respect you if you listen equally to everyone and you take into consideration everything everybody has to say. And I know this isn't a technical answer, but I would just say be strong, don't assume anything. You know, you're going to work with jerks out there and you have to deal with them and it's not very pleasant. And sometimes they do get me down, but I try not to let them get me down because, you know, I try to be a strong person and do the things that I want to do and know that I can do them. So that'd be some of the stuff I would say to them.
Okay, Christy, thank you very much. That was excellent.